Good afternoon, everybody. My name is Dino Esposito, Andrea, Saltarello here, to talk about CQRS and event sourcing, offering you a practical and pragmatic view with a bit of theory but a lot of examples. Just a couple of questions to help us tuning the examples. Anybody here attended my pre-con on Monday? Quite a few. And the talk we had yesterday about DDD, a lot of people. Thank you. Okay, let's start. A bit of related content. Of course, not for the vast majority of you who already attended the talk 211, Domain-Driven Design Patterns in .NET or whatever was the title, the exact title. But for the others, this talk in gray, because it was already done yesterday, could still be some related content you want to look as a sort of prerequisite for this session here. Another session we will recommend should take place Friday is from Julie Lerman, EF model partitioning in a DDD bounded context. Beyond that, there is the book here. Now, a few of you, yes, I guess a few people here today had some troubles getting books. So some of you, I mean, on a first come, first served basis, should be able to get a free copy of this book. I've been told that these books are at the booth, so the DevTools booth in the Hall 7. All the source code we're going to show today is available on codeplex.com, and if you don't mind, please consider following us, and even more importantly, like our Facebook page, because we are so close to the 1K milestone. So if only a few of you like us, we're so happy. What we are really covering? Well, we are talking about two things, essentially, CQRS and event sourcing. So two patterns for building systems. Usually, the word systems in this context is also associated with the term enterprise. One of the points we make today is that not necessarily CQRS is for enterprise, and enterprise usually means very complex, very sophisticated systems. In our opinion, CQRS is the best fit for the vast majority of applications today. In a way, CQRS, can we say that, is the next CRUD. CQRS is about having your logic split in a read and a command stack, with events being a plus whose introduction in the architecture is essentially related to the level of complexity and the nature itself of the domain. Event sourcing is a more advanced kind of thing, in the sense that it's newer than just the idea of CQRS. It's more intrusive in what you do, because it brings the idea that the primary source of information for your system, so the data source, are events. So when we consider event sourcing, we are also considering reducing or even not having at all the classic relational storage. In this regard, event sourcing is something, well, it can help me, but I want to know, I need to know more. There is one big problem leading people to what today is called CQRS. But if you look at the slide, the R has a different color compared to the other letters. Now, the acronym CQRS stands for Common Query Separation, or segregation, if you like. This is a concept that in the history of computing and in the history of software design, software engineering, was coined back in the 80s, in the late 80s, by Bertrand Meyer. So it's a very old concept, based on the observation that, look, when we plan to write software, what we do is essentially coding some behavior, some action against something we call generically the system. This kind of action can be a command or a query, but not both at the same time. A command alters the state of the system, whatever state means, and it doesn't return data. It's just an action. It's just the implementation of some behavior. The query does the opposite, takes the other direction. So it reads data and returns data, but it doesn't alter the state of the system. Now, why CQS is now called CQRS? Why the R? The R stands for responsibility, and it's essentially a very recent, it's a few years old, implementation, practical implementation of CQS, where the responsibility just tells us where the separation, where exactly the separation applies. And it says, well, it happens in the business logic, so at the level of classes, at the level of class libraries, in the implementation of the business logic for a system. This is a CQRS, but why CQRS is so critical and is so important to learn about? We are coming from a decade of domain-driven design. In the last decade, domain-driven design was pushed, rightly, as a methodology for complex enterprise-level line of business applications. But along the way, we found out that doing DDD according to the guidelines found in the Blue Book of Eric Evans, which is the book that offered DDD to the masses of developers, doing DDD that way was hard. And doing DDD that way meant essentially having one huge model to represent whole things that could happen in a business domain. So we observe, as architects, we observe the business domain, we make sense of the features we are going to implement by looking at requirements, by making sense of requirements, by talking to domain experts, and after that, we think, we devise a model for the domain. In the end, the DDD is design driven by the characteristics of the domain. But when it comes to physical implementation of DDD, the huge model is sometimes, often, and this comes from out of experience, real world experience, too complex to handle, and even too complex to write. So DDD itself, as we saw yesterday, offers the tool of the pattern of bounded context to split the huge domain in smaller pieces. But then each of these pieces, called the bounded context, needs to have its own concrete software implementation, software architecture. And here is where CQRS fits in. CQRS is just one way to code, to implement one of the bounded contexts, possibly all of the bounded contexts you have identified in your DDD analysis leading to the top-level architecture of the system. So CQRS, splitting commands and queries, gives you another level of split. So the original domain is split in multiple bounded contexts, and then each bounded context is split into stacks, separate stacks, commands and queries. The result is that the granularity of the libraries, classes, the code that you write is much smaller. And more importantly, each of the smaller pieces you focus on are, for the most part, totally independent from one another. If this is the classic layered architecture of a domain model, presentation layer, application layer, which is where you have the part of the business logic that strictly depends on the use cases you are going to code, the domain layer, which is where you put the part of the business logic that is invariant to use cases, and then the infrastructure layer that contains cross-cutting concerns, primarily persistence. From this, we move to a scenario where presentation infrastructure, we split, we draw a sort of vertical line, and then on the command stack, we have a path that from presentation moves down to the infrastructure to alter the state of the system, and on the other side, from the infrastructure layer up to the presentation layer, we have another block. What we find in the two blocks is essentially in the command stack, application layer and domain layer. On the query side, we just have data access. For the most part, we need no logic, or very simple, very basic logic that hardly exceeds the boundaries of some application layer, and for sure, just the query, the SQL database storage query. Okay. CQRS is highly recommended, at least for further discovery and investigation, because of the impact it has on the overall complexity of the system. In the past, we faced a lot of complexity in building, thinking, devising models. And because architects and developers have a huge ego and think we are like God and we must be able to model everything like God. I'm not God if I cannot model it. And I'm not a good God if I'm unable to design the system I see has a single model in which, single mechanism in which all gears work perfectly. When we failed in doing so, we thought, well, it's not me. It's the inherent complexity of the domain. And this is right. But we were also using the, well, if not wrong tool, we were using a less than appropriate tool. Just a quick look at this computational measures. If we call C the command, the complexity of the part of the domain that contains behavior that alters the state of the system, and Q, the part that contains data access and read, well, when we go with a domain model, essentially the overall complexity, the order of its magnitude, is probably the Cartesian product of the two quantities, which may lead to some sort of exponentially growing complexity as the system becomes larger and richer of business rules to handle. When we start thinking with a CQRS mindset, we treat the command stack and the query stack as separate entities, so the overall total complexity is just the sum of the two quantities, which is probably a linear quantity. So, CQRS. There are several flavors of CQRS. We have selected the 3 flavors that are most popular, like you are in a Starbucks, right? So we have a regular CQRS. And a regular CQRS uses in the command stack a very simple and very basic pattern, transaction script, which is one of the patterns for organizing the business logic that years ago already Martin Fowler made popular and discussed and explained in his seminal book, Principles and Patterns of Enterprise Application Architecture. Transaction script is very simple. It's just a transaction that starts from the user interface request and ends with database access. It's an end-to-end, all-encompassing container of code. It's a logical transaction that scripts whatever you are expected to perform, the entire workflow associated with the use case triggered by the user. On the query stack, we have essentially very simple things. One of the approaches we can take in the query stack is called let. People who attended the talk yesterday and the pre-con know already what let is. We will be demonstrating let later today. So let is it's essentially link, a special way of using link on top of a link provider, for example, entity framework. Or just plain SQL, whether through ADO.NET, storage procedures, or whatever else. Services, why not? Whatever else you have to just read the data. Premium CQRS is more sophisticated in the sense that we use a domain model implementation in the command stack. Look, but Dino, you said 5 minutes ago that domain model is gone, being replaced by CQRS, and now domain model. The domain model is just a class library, object-oriented class library, that describes the behavior of entities and relationships. But in this case, having a domain model simply means having a domain model that describes only the entities and the behavior related to the command stack. So it's a very, very simple domain model compared to the domain model we are expected to have when we consider the entire space of a bounded context. So it's the order of magnitude story that I showed on the previous slide. It's a domain model, but the complexity of this is much smaller than the complexity you would face otherwise. On the read stack, we just have an ad hoc read model. Now, there are a few things to be said that will become clearer as we go ahead. The Deluxe flavor of CQRS has a domain model on the command stack plus optionally events and possibly even sourcing. And it has the same ad hoc, the same options for the read model in the query stack, with the exception that if we are using event sourcing in the command stack, we might want to have something called data snapshots, a special type of storage, so a storage of special data in the query stack. A look at storage and persistence. In the first case, when we consider the regular flavor of CQRS, we are considering essentially a scenario where the command and query stack share the same storage, whatever. The simplest and most obvious case is thinking of a SQL Server database. In the premium model, we typically have two distinct forms of storage, one for the command stack and one for the query stack. And keeping those two in sync, it's an aspect that should be further investigated. So how you do that? Most typically, the command stack contains some extra layers of logic that just keep up to date the ad hoc read storage so that every subsequent query can read the up-to-date state. And finally, in the Deluxe flavor of CQRS, we have multiple storage. The storage for the command stack, which contains the current state of the system. If we are using event sourcing, it could be the event store, so where we log all the events that took place in the system. And we can have also the read model articulated in several different storages. For example, graph database, document databases, ad hoc relational tables, what is generically called the polyglot persistence. Now, Andrea will give us a demo of the regular CQRS and implementation, and the transaction script, before Andrea shows us, is very, very simple pattern, task-based, end-to-end use case implementation, in which you have one transactional, logically defined transactional method per each user action. No models, nothing, just DTOs moved along the path from top to bottom. It's a just works approach, and, well, it's a sort of money-back guarantee. It anyway works. On the query stack, we expect to have a link to entities involved, or perhaps ADO.NET, and also in this case, just plain data transfer objects.
Hello, everybody. Today I'm going to show you some code, but let's start having a look at the application first. Source code is available on Codeplex, and the application is called MERP, which stands for Mini or Micro ERP. Just a couple of features. Just one that allows us to understand a typical regular flavor of CQRS stack, implementation stack. So those are some company business units. Let's just choose one. Some not so fake data. We have the balance. We have the current job orders. So these are the projects we're working on too. And we also have the expired issued invoices and the expired incoming invoices. We can also create new projects, nothing fancy at all. I can just choose a customer and a contact. I'm the manager, and so on. Okay? Really nothing fancy. All the data go to a plain SQL database. Sorry for the font size. The more interesting part is understanding how to implement such a simple feature using the regular flavor of CQRS. So it all starts from a plain razor view, which has a view model. The view model is one used to gather data from the UI. A bunch of rules specified by means of the data annotation attributes. And we have the controller. The controller just checks for the data annotation rules and then calls the application layer. So that's the part of the business logic that pertains to creating the use case in the DDD jargon. The application layer just call the command. Using the transaction script pattern means to have commands defined as functions, just plain function. One function per command. And that's where the domain layer starts. Oh, no, we're not interested in the constructor. And so we have a command that actually should implement the domain logic that checks whether the job order can be created. Maybe the customer is not allowed to be chosen because of some business rule. And we just use an entity framework bucket object context in order to save the data. This entity framework object context is a really simple one. It has actually been reverse engineered by the database, which is an unusual scenario when we have to create new application. We already have a database. And so I did reverse engineer a database and applied a custom transformer in order to create both the DB context and entities. Plain POCO objects. So the command stack is really simple, using this style of CQRS implementation. But let's have a look at read stack, which is the one we do use in order to know which are the current job orders or the expired invoices, whether they are issued or incoming. So, as Dino told us, we should expect to have some kind of read-only model. And at the first sight, an entity framework model is a read-write one, because we just call the save changes method on an active object DB context, actually. And that's why we did also define an iDatabase interface and that's the interface that we're injecting in an application layer. So models, views, worker services, and that's it. That's the application layer, which requires an iDatabase instance. Let's go checking the controller. And the controller has a reference to the application layer, and all the references are resolved by an IOC container. We are using Microsoft's own Unity, supported by the enterprise library. You can just add a reference to the Unity package by means of NuGet. And that's where we are registering the application layer types, resolution rules. So Unity does resolve the controller, creating the application layer instance and giving this instance to the passing this instance as a home controller construction parameter, and that's why Unity resolves all the stack and is also able to send an iDatabase instance to the application layer. And the application layer is not receiving a proper DB context instance, so it's not aware of the existence of a save changes method, and can only use the iDatabase provided kind of repositories in order to allow the application to actually read data. Okay, that's where we build the model. We'll go back to those methods in a while, in a short while. Let's have a look at iDatabase interface implementation. So we have a private instance of the context. And being this instance only used for reading purposes, we have a chance to have Entity Framework work faster by disabling the object tracking. So this really speeds up Entity Framework when materializing object instances. Sometimes I hear that Entity Framework is slow. It can be slow, but it is not slow per se. It just asks us to give him some love. Okay? So, all the repositories are a mere facade on the built-in one supported by Entity Framework context. And let's just have a look at where we are building the list of the expired invoices. Okay, let's let query. I just want you to have a look at this syntax. Dino is going to tell us something interesting about this syntax, and then we're going back to the code. So, Dino, it's up to you.
So, to summarize, the point about the read model is wrapping everything that can be read, that we want to be readable, in a wrapper interface. We call it iDatabase. And iDatabase, in its implementation, contains a private DB context for actual data access, and all the collections that are typically exposed as DB sets are instead exposed as plain high queryables. This makes the model just read-only. So, again, as I said repeatedly in the past days, and I'm happy to repeat that now, when you design a model, domain, CQRS, whatever, you are designing the API of the system. So it's your specific responsibility as architects to make sure that only things that are consistent, coherent, legitimate can happen. With this approach, no way that nobody can make a change to the database, because save changes on the DB context inherited class has just been hidden. So, the query that Andrea pointed out uses an approach that we call LET, and LET is an acronym for Layered Expression Trees, which is just an idiom. And we use this idiom essentially to bring the ubiquitous language, so the language of the business that we recognize out of requirements, also into this part of the system. In the related content, talks and slides and whatever, you may learn from there that the ubiquitous language should be kept in sync, so that the terms in this language should be kept in sync with the naming conventions you use to create whatever class serves your purposes. But here is that we do the same also when we read. So, in the end, let is a plain composition of iQueryable extension methods. So, in this way, we bring iQueryable objects up to the application layer, and we close the query only at the last minute. And we specify the projection of data we want at the last minute. Look, we are not talking about using link to objects. So no way we are talking about downloading 1 million records and then filter the 3 records we actually need to display for the presentation. We are talking about building the SQL query step by step as we move from the bottom to the top of our read stack. We gain a domain-specific language kind of expressivity. So, let's say that we have a query like this to write. As a business unit manager, I want to collect credits for all outgoing invoices still unpaid. So, we have a database. The wrapper, the public container, the public access to whatever, to the entire read model. Issued invoices is normally the DB set, one of the DB sets of the mapped database. But in this case, because of the iDatabase interface, that's just an iQueryable object. So from the issued invoices, we call a method called per business unit, and we pass an argument over there. It's a filter using this business unit ID, and then filter furthermore using the unpaid method. Now, per business unit and unpaid are both extension methods, part of our project. We created as iQueryable extensions just to use the ubiquitous language while querying. At the end of the day, per business unit and unpaid just add further more clauses to the where part of the query. After that, we select what? Here is the projection of data we want to capture. And this is, in this example, data we actually select from the data, and invoice number and customer ID here are, if you put this code in the application layer, so as close as possible to the actual razor view, if you are using ASP.NET MVC, these are just pieces of data that you want to display, you want to pass to the razor view. Andrea, back to see in concretely the code in those extension methods.
Oh, okay, guys. I'm sorry because this is the very demo where I'm going to disappoint you. Why? Because let's have a look at the query once more. So we're asking the database to give us the expired invoices of a specific business unit. And we want these invoices to be ordered by expected payment due date. And we are producing the projection of the data that is going to be given to the razor view. So just one query to produce the very final DTO, the one which is consumed by the UI, and we are just creating a single query composing different rules created in the let idiom style. And let's have a look. Our disappointing look. So, per business unit is an extension method for an iQueryable of inbound invoice. Those are custom link operators. We're used to use the custom link operators, which are select, average, count, where, whatever. And they also work the very same way. They just get an iQueryable of T instance, and they give back a different sequence, which is also an iQueryable of something, And the resulting sequence is the one which has the operator actually applied. So our database structure is very simple, so do not expect any kind of fancy database schema. It's just an example. And so we have the invoices pertaining to a specific business unit, but we just want the expired ones. An expired invoice is an unpaid invoice whose due date has been exceeded. So let's have a look at the expired. The expired rule takes advantage of the unpaid ones rule. Okay, and now it's all about our specific link to entities provider, which in this case is the SQL Server one, to be able to produce an effective query that is going to produce the desired data set that goes straight back to the UI. And that's the disappointing way to implement the LED idiom in such an example, such a business context. So, Dino, back to you.
There are a few things to be mentioned about this approach. In first place, we are moving iQueryable up the stack. So this approach won't work if you have tiers. If you query for, if you Bing, okay, not Google. If you Bing, we have a big brother. If you say Google, Bing, if you Bing for iQueryable and anything, any keyword that may be associated with this content, you find objections from the masses, from the developers community about this approach being possibly a leaky abstraction over iQueryable that makes your code too much dependent on the capabilities and the performance of link providers and whatever is underneath link providers. Yes, this is a good argument, but only if your application under your control is going to switch different databases on per customer basis. But if you stick to just one storage and you are confident and comfortable with a link provider of choice, there is no reason that you're going to have a leaky abstraction on top of this. As far as the point of serialization of iQueryable across the stacks, which ends in the moment in which you use tiers instead of layers, that's a good point, but on the other end, it depends on how you consider, how you plan scalability. Because an excellent way today to consider scalability in your systems is having everything deployed, delivered, implemented as a single layer, and then you just duplicate. You put this layer into a web role, a web job, and then you just horizontally gain more power just duplicating those instances. In this context, let works just perfectly. Another comment I want to make on this point, in general on the CQRS regular flavor, is we are having here just one database shared by queries and commands. So if you have a scenario where you need to do some work on top of the data you physically select, if there is some sort of gap, conceptual gap between the persistence model you get in SQL Server and the format you need to display to the user interface, well, this logic needs to be placed somewhere. So probably you can reason about extending. If you want to stay close to the ubiquitous language, you can probably consider, but it's just an idea, consider using extension methods on the iDatabase interface, business specific, but that's just an idea, or introduce repositories or intermediate layers, or just put logic in the application layer, or even in the razor views. It depends on the situation, the skills, and even the gut feeling you have about this point. So let doesn't specifically address the scenario where you have some business logic to pre-format the data you are bringing up to the user interface in the end. Premium. We assume to have distinct storage for the command stack and the query stack. The domain model is used in the command stack because you reasonably have some complexity. The domain model in the end is just one way, is just the way in which you organize the business logic, and this means the code that handles the business rules you have. Domain model focuses on just the behavior that may alter the state of the system. On the query stack, that's interesting. Things change now if we assume we have a separate database, because the business logic that helps preparing the persistence model to look exactly what we expect to have in the views can be solved using a table per view strategy, which means that the Q database here contains up to one table per each view, where view here just means possibly razor view. The idea is that all the logic you need to massage persisted data to view data takes place in the command stack, and the command stack is also responsible for updating, for writing records in the Q database as soon as commands are processed. And once you have one table per view, all that you have to do is just running the query. And at that point, you need no extra logic in the query stack, and let, in this case, works just perfectly. The performance is maximum. More, if you have the need to scale on particularly high numbers, nothing prevents you from taking the query stack and offloading that to a specialized machine, a specialized cloud, a more powerful cloud. You can handle and optimize the two stacks independently. This is one of the key factors for the adoption of CQRS as a pattern for a bounded context. Deluxe. Before we look into Deluxe, another comment. Let me switch back. Domain model in the command stack, table per view ad hoc storage for queries in the query stack. One of the key things that change here is when you have a domain model, you pay a lot of attention to the types you use in the model to model the entities. So if we are talking about orders and orders made of order details, an order details has a quantity, a product, and maybe a price. But a quantity is technically a number, an integer. But in the business domain, it's a quantity. So in an ideal design of a domain model, you are not going to use an integer to express the quantity of an order detail, but you want to use an ad hoc value type called quantity, which is just a wrapper, an immutable type built around an integer value. But when it comes to bringing the same information for view in a table per view, you can even render that integer, that quantity, has a plain string or just as a plain integer, because it's read-only. And once you have guaranteed, your logic guarantees that the transformation, the creation, the synchronization between the C and Q database has been done correctly, whatever you read from Q, whether it's a string, a number, or whatever, just exists for the sole purposes of the presentation layer. And on the presentation, you just display characters. You have no interest in knowing more about the actual types. Deluxe, domain model and command stack, just the same. Just a further note about focus on behavior that may alter the system state. We are talking here about whatever can happen in the system state. So not necessarily just writing a database. For example, in a booking system, You send, and your system sends an email to the customer who bought something or booked something. The email has been sent. This is an action that is nearly impossible, or anyway, quite hard to revert. So it's a state change. From the perspective of the business, sending the email alters the state of the system, even though for a bug or whatever reason, nothing gets written in the database. In the real world, once the customer goes to the hotel and shows the printed email with a confirmation number, it doesn't matter whether or not the system has that confirmation number. By sending the email, the state of the system was altered, and well, the domain business and the logic here must be able to, to cope with whatever really alters at the business level the state of the system. In the Deluxe flavor of CQRS, in addition to the domain model, we use events for concatenating microtasks to form the workflow we want to execute from any trigger we get from the user interface. The user pushes the, say, checkout button in an online web store. A workflow is expected to execute. We express the steps and the concatenation of steps of this workflow using commands and events. And events, optionally, as a further point of complexity, can also be used as the primary data source of the application. The storage, same story, table per view, query through let, and if we are using events as data source, we also have the extra possibility of using data snapshots. Data snapshots is when you use event sourcing, and event sourcing means that whatever happens is logged, and that's the state of the system. So data snapshot is, okay, I group together related events, everything that happened to a given order when it was created, when it was modified, when it was processed, when it was shipped. For each of these state changes, there is a proper event. So event sourcing is about logging these events, but then if you want to know the state of the order 1, well, you need to query all the related events and either replay those events in memory up to building a valid instance of the order class, first created, then the various states changed, or as a matter of improving performance, whenever you save, you record, you log an action that modifies the order state, say, you also create a snapshot of that order in a specific database, a separated database, which could be a document database. You just save the object for, say, RavenDB, MongoDB, or it could be, I don't know, some sort of relational table, whatever works for you. So this is the green points you see on this slide. And now, have a look at commands and events to express the business logic in a Deluxe CQRS flavor.
Okay, let's go back to Visual Studio. Very similar use case. So we have a different version of the MERP application. We have two bounded contexts, just to use the DDD jargon, the registry and the accountancy one. And we're going to focus on the accountancy one and have a look at the very same use case. So we're going to talk about having job orders, all job orders, or only current job orders. Every job order has some kind of detail, has a balance, and we could create new job orders that specify a name and whatever, date of start, due date, the price, and whatever. So let's go back to Visual Studio. Just a couple of informations relating to the solution structure. We have two bounded contexts, accountancy and registry. Each bounded context does support two projects dedicated to query stack and the command stack. So we have a view, we have a controller, that's the accountancy area of the ASP.NET Embassy project. We have the job order controller, and then the create fixed price action. So let's search that action. Accountancy, controller, job order, create fixed price. We have our usual view model. This is a plain view model decorated with some data annotations. And that's the action that is called by the UI in order to actually create the job order. This is the call to the application layer we expect to find at the presentation layer level. Let's have a look at it. And now we have something different, because we're not calling, we're not invoking a function anymore, but we're just building an object which does represent the command. Let's have a look at the command definition. It's a plain class that inherits the command class. We'll have a look at that domain class in a short while. Please notice that all set accessors are private because commands are immutable. Okay? That's where we're asking the system to actually perform an action that could end in altering the system state. We have the constructor that sets the properties. And then we put the command instance in the bus. Okay? We can have a look at the bus definition in the infrastructure project, which is located within the infrastructure folder. That's what the bus allows the application to do, just sending commands and raising events. But we also have a bunch of methods, of register something methods. Register Sega of T and register handler of T. So let's have a look at where we do use these methods. We have a bootstrapper class in this project that has the same very meaning of the one we had in the previous project. And that's where we are going to register, to actually register the bounded context, one function for bounded context, configure accountancy bounded context, and we're registering some handlers. We will be back to handlers in a while, and we are registering the workflows. Workflows are called Segas in the DDD community. And that's where we are saying that we have 4 workflows pertaining the management of job orders and invoices. Let's have a look at the fixed price job order Sega. And this is the very definition. It is where our class actually says, okay, I am a workflow and I am started by this command, which actually is the command we did send by means of the bus in the application layer. Okay? We're not going to bother a lot with the actual implementation of the bus, but just to be crystal clear, what the send method implementation does is to dispatch commands and events. So back to the Sega. I am started by this command. Okay. That's where we actually handle the command. Let's have a look at the am started by interface definition. Nothing fancy, very simple, just one method, just one handle method of T. That's why we have to implement this method for our Sega to compile. And then we're going to start talking with our domain model. This is the fixed price aggregate or cluster of objects that represents both the data and the behavior of a job order. And we're asking the factory, the job order aggregate factory, to create a new instance. And that's what that factory actually does. It does create the aggregate instance, setting all the properties. It does create an event instance. An event is an object, quite similar to the command. An event is something that happened in the past. That's why we have the registered suffix. And all the event setter, property setters are private too. And so we have now an event instance. And we're calling the raise event method. The raise event method is implemented by the aggregate base class. It is the base class used by all domain model root classes. The raise event method, which is actually protected, adds the event to the list of uncommitted event, which is a private A list of domain event, which is the base class of all our domain events. Now what? Let's go back to the Sega, because we're just returning the aggregate instance to the Sega. Okay. And this is where we are actually going to save the aggregate instance. The save method implementation go to definition. Okay, let's have a look at the implementation. Wow. Very simple algorithm. So, we are going to actually save all uncommitted events to the event store, which is a database. This application does use an embedded instance of the RavenDB database. Okay? We did use an embedded instance of the RavenDB database, so to have you be able to just click F5 and starting the project and have the DBMS running. Okay? No need to configure anything. You can just have a look at the Raven Studio, the console, navigating to the 8080 and 8081 port of the localhost after having started the project. Okay? The second thing we're going to do is to actually save the aggregate in another RavenDB database, because we are actually saving a document. A job order is a document in the accountancy space. An invoice is a document in the invoice space. There's no foreign key in an invoice. You just have this sheet which stores all the customer information. Just one document, and we're going to persist. Nothing fancy. That's where RavenDB does the magic. Okay. And so we have persisted both the uncommitted event and the aggregate. Now what? The manage uncommitted event sends all these events back to the bus. And that's where the system is allowed to actually react to those events. How? Simply having interested subscribers, such as a Sega, actually implementing another interface. Which is a iHandle message. The iHandle message interface is quite similar to the I am started by one. The only difference is the name. And now let's ask ourselves, who could be interested in such an event? Well, let's go back to the bootstrapper class and have a look at all registered subscribers in the accountancy bounded context. So we have Segas, and we also have handlers. And let's have a look at the project sporting the query stack of the force. And we have denormalizers. Well, so we have this class that does not inherit the Sega class, but it does indeed implement the iHandle message interface. And this is the class that actually tell the system, hey, I am interested in the fixed price job order registered event, or in the fixed price job order extended or completed, in all the events that pertains to the job order lifetime from a workflow point of view. And that's where we actually use the entity framework to actually persist a snapshot, a last known entity state snapshot of the job order. And that's where we could also be able to substantially, to basically implement on-the-fly calculation, such as, okay, some guy did associate an incoming or issued invoice to a job order, or whatever form, kind, type of cost or credit associated to a job order. And by means of a similar stack, the application is going to send a command to the bus, and that command is going to be dispatched to a SIGA, which is going to actually call a method on a job order instance. Fixed price job order, mark as complete, extend. Let's go to the base class. Associate incoming invoice, associate outgoing invoice. So we have all the domain model behavior implemented within the aggregates, the job order class. And every method does check whether a domain rule has been violated or not. Okay? That's where we are looking into the event store in order to check whether that invoice has been already associated to an invoice. In order to have this method called succeed or fail. Both ways we're going to raise some kind of event. Success or failure are just events in an event sourcing solution. Okay? That way, we're going to actually save events in the event store, which is RavenDB. You can have a look to navigate into the 8080 port. So, company registered events, or fixed price job order registered events. Just one more thing. We could also have the normalizer applying calculation on the fly in order to have our database exporting the very last known state of each entity. Okay? And so that's the database that is going to be read by the application, the MERP database, by means of a plain entity framework data model. A plain DB context code first database. But we could also take advantage of the event stream in order to have the job order be able to calculate the balance at any given point in time. Because we can go back to the event store and use every event that associated costs or revenues to the job order, and use those events in order to evaluate the balance. Okay? I hope to have shown you the very gist of CQRS and event sourcing solution. Now back to Dino.
Okay, to wrap up things, Deluxe means that, the CQRS Deluxe flavor means that the application sends the command to the system for each user interaction typically. The command takes effect in some way. The system state changes. Changes are notified through events to register subscribers, also known as handlers. Typical example of handlers or subscribers are sagas or workflow managers, to use the Microsoft terminology, the PHP documents, patterns and practices group documents, and denormalizers, which are typically used to generate ad hoc views for the read stack. Events are notified and commands execute through a mediator, a bus. Okay? Now, graphically, the same. The application sends a command to the bus. The command hits the domain layer where we have the domain model, domain services, and handlers, sagas, or denormalizers. As the command executes, an event may be pushed back. It's typically pushed back to the bus for other handlers or denormalizers, whatever, to kick in and do their own job. That will affect the state DB, so the event store. So depending on the way in which we save, we intend to save data with the state of the system. Some specialized handlers, denormalizers, receive some events and they just create the ad hoc database for the query stack. And the read stack reads information from the ad hoc DB and brings that back, typically in a straight way, possibly using let or plain ADO.NET SQL queries up to the presentation layer. The bus graphically stops at some point, which indicates essentially, imagine an horizontal line just underneath the bottom of the bus that gives you a graphical idea of what is the command stack and what is the query stack. Now, what about just a couple of words, a little bit more than 2 words actually, on tools to finish off. Tools we can use to arrange a CQRS solution, especially a CQRS Deluxe solution. SQL whatever for storage is a good solution depending on the skills of people involved in the project. They are good solutions because of the ecosystem of tools, extremely rich, and SQL solutions are available both on-premise and the cloud. MongoDB is free, so you don't typically pay licenses. Available on Linux and Windows, on-premise and cloud. It's good because it's schemaless. Similarly, RavenDB, schemaless, great or good enough link support, support for transactions and DTC, on-premise and, well, especially on-premise, but also some offerings appearing for the cloud. For the bus, we have the option of MSMQ, which is kind of expensive, especially because it requires quite a bit of code to be arranged. But it's still definitely an option. We could say more or less the same also for service bus. And service bus, instead, is a commercial product that wraps up MSMQ, and even service bus. It does the same job as, say, MSMQ, except, that's the added value, it offers really advanced config options and features. And Even Store is an emerging tool. It's an open source project, free, that supports the full DDD CQRS event sourcing stack. And essentially, it has the role of being a one tool you use to do event sourcing and create separate command and query stack. But it's, again, an open source project. It's an emerging one. If you're looking for something really stable for a range, a solution, or if you have constraints in your company that prevents you from relying too much on open source products, well, it's something to consider, but probably it's not ready for prime time. Okay, we're done. Again, we have been told that a few copies of this book are available for free at the DevTools booth. I'm probably going to be there for at least half an hour, probably an hour, starting from now. Code from the Codeplex website you see over there. If you like the presentation, like us on Facebook. Thank you.